E.O. Wilson is here. He is one of the world's most distinguished biologists and naturalists. He has written 30 books, won 2 Pulitzer Prizes, and is a professor emeritus at Harvard University. His new book grapples with some of life's most fundamental questions. It is called The Meaning of Human Existence. I'm pleased to have E.O. Wilson, as I always am, back at this table. Welcome.
Thank you.
Now, you are how old now?
Well, I'm 85.
Yeah.
And it's beginning to slow down age, but I don't quite feel that way yet.
Yeah. Here's why I ask. As I was saying to you when you sat down, it seems like you were just here not long ago with another book. Yes. And you said to me, 3 in 2 years. And I said, is there some sense of urgency that you have these things that you think it's important for you to say now?
Yes, I said that. An 85-year-old may have 10 more years. I'm not counting on it.
No.
And I just want to make sure that if I have anything worth saying, I get it out.
And so tell me how you came to the meaning of human existence.
Over a long, long route. I started my career as an evolutionary biologist. Yeah. I actually invented that term. That makes another story, very interesting. But in the course of studying every aspect of the biology of ants, I became interested in the broad subject of social behavior,
right,
the biological origin of social behavior. I wrote a book entitled Sociobiology and so on, and other related books.
That became a bit controversial?
It did. We settled that in the 70s, though,
yes.
And now it's not controversial.
Right.
But this led me to human behavior, inevitably. I mean, after all, we are social animals.
Right.
And eventually, it just seemed logical where I found myself positioned to think about some of these big questions that philosophers and even religious scholars have largely abandoned.
Go ahead.
Yeah, which are, where did we come from? What are we, and where are we going?
Yeah. And what does it mean to be human?
That is correct.
Which is this, the meaning of human existence.
Exactly. From the point of view of combined science and humanities, I think we're approaching the time now where the appropriate disciplines of science have learned enough and are moving enough in the right direction so they can connect with the best of the humanities to create a much better picture of who we are. And where we came from than we ever had before. In fact, I'd like to refer to it, what's happening, or at least will happen shortly, as the New Enlightenment. The time has come for us to renew it.
Define the New Enlightenment.
Yes, I think we are ready now.
Okay, but help me define what it might be. What are the
Well, the original Enlightenment
strokes?
Was a period primarily in the late 17th and throughout the 18th century, in which philosophers and scientists, they didn't call them that at that time, but those who were called natural philosophers, the first scientists, were in agreement that they were learning so much so fast that in short order we would be able to combine all that knowledge and come to understand humanity in the light of, knowledge that we could acquire ourselves and not just rely on
so much had come in and so fast there was time to step back and say, what have we learned and what do we make of it?
What happened was that the old Enlightenment faded away because of 2 developments. One was a Romantic period of literature.
Right.
It came to dominate a lot of English, the language, but also it was that science could not deliver, not in the early 1800s, and so its promise of actually contributing something fundamental to the question, what is the meaning of human existence, that faded away, and we had to wait for 2 centuries. And now, after 2 centuries, I think we're ready to ask those questions again with a lot more confidence.
Well, but also much more challenging because science has roared ahead and challenged traditional definitions of what it means to be human.
That's exactly right. Let me just say about this, too. It isn't just science that holds the promise of connecting with the humanities and renewing the quest. I think we're close to finding the Grail, but just not any science. For example, you're going to get nowhere if you ask an astrophysicist, an astronomer, You're going to get nowhere on this question if you ask a chemist. Even my colleagues among the molecular biology, they're just too far removed from what we need to know about where humans came from,
right,
where they fit, in the Earth's fauna and flora as a species that evolved from something less than human, pre-human, into our present self-glorified form.
So where do we find the answers?
Where do we find the answers? Let me list 5 disciplines where we are finding the answers. And these, a couple may surprise you. We are finding them in evolutionary biology, which is advancing with the help of genetics, molecular genetics, and the other disciplines advance itself very quickly. Evolutionary
is this about mapping
biology.
the human genome, or is it more?
Well, I was coming to that. The next one, what we need to know that's contributing and will contribute big time is brain science,
right,
and we're of course that is now the subject of immense interest and intensity of research. But the third one, of course, is, as anyone would want to list, would be paleontology,
yeah,
and archaeology. They, sort of segueing into each other. But then now come the 2 surprises, would surprise people, I think, pretty much. Artificial intelligence,
yes,
and robotics. These are the branches of science and technology which are attempting, actually, to understand how the human brain works, and thereby just what evolution has produced.
Yeah, now, I know a little bit about this because we have conferences, and I'm asked often to participate in the meeting. We've done, 2 complete years of conversations about the brain. But when you get to artificial intelligence, there are some people, and very wise people, who are scared about the consequences of this. Does it bother you?
Not in the least. I just had the opportunity of meeting with 6 of the key figures in artificial intelligence and robotics. They had gathered to receive a prize, and
right,
I was there, and we arranged for a roundtable discussion on the present status of those subjects. And in my case, we were bringing in biological diversity. How is this going to affect the living environment of the world when we start filling it up with robots and changing our consumption patterns and so on?
And the answer is?
The answer is, because this became an ancillary subject, are the robots going to take over? That's great. That's a great story, and Hollywood loves a great story, and so they tell this story over and over again. The short answer is no.
Because?
Because we have control. We are not going to allow even advanced humanoid robots to evolve.
Wait, you're saying we can control it, so we will not allow it because we will make sure we understand the danger of it, and therefore we will put a barrier.
We will bring it short. We just haven't even begun really to understand how the emotional centers that are the core of our human nature, how they work. We're just locating them right now, the brain mappers.
Yeah, but in the last 10 years, we've made a lot of progress.
Rapid progress. But that being the case, and understanding that we're just beginning to find out where all those subconscious centers are and how they feed into the imagery, this white-hot, intense area we call the conscious mind, we are not likely to be able to duplicate or try to duplicate that in robots. But if we were to try to duplicate it, we're certainly not going to give the robots the chance to evolve.
If we could, we're not going to give it to them.
Yeah.
All right, but here's the question with that. That's very nice to say, but there's probably somebody out there somewhere who says, I don't particularly want to follow E.O. Wilson's definition of where we should let the robots evolve to. I want to see how far we can take it.
Well,
and
you're right. That's the mantra of the techno-scientific age. There will be no halting of any scientific investigation or potentially useful technology because it is human. It is our human nature, the core of our nature, to want to explore and keep exploring always. But there's a big difference between the mad scientist who's invented a great new neutron bomb on his own in his private laboratory, and teams of scientists working that are needed to produce the ability of robots or artificial intelligence of any kind to mutate and to go through natural selection. I think those who make up the good stories for us from Hollywood don't appreciate exactly what selection is, natural selection and artificial selection.
All right, let me go back to the five. One is evolutionary biology, neuroscience, artificial intelligence, and robotics. What were the other two?
Evolutionary biology and brain science.
Brain science, that's the first two.
And
third is
paleontology.
Paleontology.
And archaeology.
That's one or two?
Well, they segue into one another. I mean, when you get far enough back before, so you're not dealing with the artifacts of culture so much, but as the anatomy and capacity, then you're now in human paleontology, it's called.
Now, here's what I thought this was. When I first picked up this book, before I read it, I thought, here we go with the revered E.O. Wilson has decided to say, we are creating human life in too many ways in which we're trying to design human life. And that's not such a good idea. That somehow molecular biology and the capacity to do all the things we have learned about gene therapy and the capacity to tinker with human evolution has put real power to change what it means to be human in the hands of people with certain skills. That's what I thought you were going to say.
No, I didn't. Actually, I think...
So that's not an issue for you?
I'm glad you brought that up, because this raises the whole issue of the importance of the humanities, which you might have noticed, the readers might have noticed. I touch on in a chapter called The All-Importance of the Humanities. And the reason I do that, part of the reason is that consider that rational abilities and rational process and the engineering and the technology that emerges from that, nevertheless is not human, a fundamental human quality. The capacity, the degree of capacity is unique to humans, but what is fundamental to human policy, what makes us a distinctive species, what gives humanity to us, may I use even the word metaphorically, what our soul is in our emotions. And we're not going to tinker with those. That's the core that we're trying to save. And we're dealing with all of the technology.
How do we avoid tinkering with that? Or you just says it's impossible, the idea of the soul.
No, I didn't mean that it's impossible. I'm just saying that when we finally settle down, if we do settle down before we wreck this planet, we're going to come to understand that it's the conglomerate and the complex interaction of our emotional process that makes us distinctive and is the core of our humanity.
Our emotional process.
Yes.
And what advancements are we making in terms of that emotional process?
Just study.
Just study.
Just studying. Right now...
There are no landmark achievements.
Well, they're a landmark in the sense that neurobiologists, and you can't really tell where they are from one month to the next. They're moving so rapidly. But right at the moment, they have succeeded in locating quite a few centers for emotion and also centers for subconscious decision making. And the idea is to learn about this as thoroughly as possible. The decisions can be anything, as was recently given the Nobel Prize for, of judging distance and orientation by a quick learning process, and what centers that is. But center by center, linkage by linkage, we are beginning to get a map of the Earth, and then, mind, and then we will be able to map the emotions and move to the next phase in, there's a nice term that's being used, and that is whole brain emulation. emulate the human brain, but not try to exactly duplicate it.
What's the difference if we emulate it? Where would we go if we emulate the human brain? It would be different if we tried to duplicate it.
We would not. I think, well, that's a very good question, sir. But the emulation means that the computing that depends upon decision making, that is has emotion-like components to it, is one of the goals of artificial intelligence. There's a kind of technology that's being developed. It's secondary in importance to digital, binary models, and that is called neuromorphic. That is computers that actually are designed to be analog and work a bit like the brain. And so I suspect that in time, neuromorphic will, that is, analog computers to imitate the brain will come by, and we will gift the robots. Now I'm way out beyond.
I like it, though.
Okay, you like it. Okay, fine. This is good. But the goal, I believe, is that we will have computers smart enough to perform the obvious complex task we want them to perform on the surface of Mars and in the middle of volcanoes and so on. But we want them also to be able to make judgments that are appropriate for human need. And so that's about as far as I think we would want to take it.
Did you ever know Michael Crichton?
Yes, I got to know him pretty well.
That's what I thought.
Even once, maybe this will allow me to escape from where you've trapped me in whole brain emulation. Yes, one day
I've just begun.
I had dinner. I had dinner with Michael Crichton, and I described in an experiment I could perform right then and there.
Yeah.
I had fossil ants, 15 to 20 million years old, entire colony in amber. I probably could have opened that amber and extracted from it substances, terpenoids, that served at those ants and serve their direct descendants today as alarm substances, that they emit to alarm one another. A smell that means danger, danger, come this way, alert, alert, to get ready to do something. And I said to Michael Crichton, would this satisfy you if I did that and actually took the signal, the chemical signal, 15 to 20 million years ago, went to their descendants and finally delivered the message? I'd have a colony in my, that species in my lab and alarm them with the 15 million year old message. Finally made it over. And he liked that. He said, did you do it? I said, no. And he said, why? And I said, look, it'd just be a circus trick. Yeah. And it would. That's all it would be. It wouldn't be science. It would be a circus trick.
How do you find time to know all that you know and to follow all these trails of human knowledge?
I don't know. I'm just...
Well, I mean, you read, you talk, you let your mind, your curiosity take you where you're interested.
It takes me in a lot of directions, and that's basically what it's all about.
And go ahead.
It's youth. I mean, that's why as you brought up early, maybe I did, I'm getting old enough now, so I'm worrying about the time I have left. But basically, I feel young. I've always, I have the same excitement over science and discovery that I had when I was just a kid.
We appreciate science more today, you think? Do we appreciate science more today?
Well, more, but not nearly enough. I wonder how many real scientists you interview here. Probably not many compared to leaders in other branches of public activity.
I would make 2 points on that issue.
Okay.
I don't do enough, but I do more than anybody else.
You do. And I didn't mean to take any credit. Otherwise, if it weren't for you, I wouldn't be sitting, anywhere being interviewed like this.
Yeah. But let's assume you were thinking of doomsday.
Yes.
Is it more likely to come, as you have talked about often, somehow what we do to the planet? Or are we going to unleash something beyond our comprehension which will have a velocity of change that we never imagined?
Both. It's a race among doomsdays as to which will come first. In other words, now we are above critical level in the concentration of the climate change components of the atmosphere. And scientists who are expert on these subjects, the real scientists, wonder and worry that there's some kind of a turning point.
A tipping point?
A tipping point that could be catastrophic in nature. And they can imagine scenarios in which that could occur. So we could do massive damage or catastrophic damage with a tipping point that we didn't anticipate well enough. And we're allowing, the potential cause of that to go on and on. So we should be careful about climate change because that could create a catastrophe. But the other way is by the means of whimper. And that is what I'm beginning to concentrate all my energies on, and that's conservation of the biosphere, the biological diversity of the world, and not let the species slip away, become extinct as they are 1,000 times faster than before humans came, because we don't know what would happen with the biosphere as we destroy it. It could mean that we just wind down to a less controllable, less interesting, and less productive planet, and that would just be a kind of dark age that we could never emerge from.
If you'd just gotten out of college today, what field would you most go to? What field would you go to?
I named that field in my autobiography, which I thought would end my career, be toward the end of my career and life, published in 1996. And I said if I had to do all over again, I would go into microbial ecology. I would work...
Microbial ecology?
I would work on microbes. We are microorganisms in nature. We know that in a single sample of soil, 1 gram, you have in the billions of bacteria, and that there are as many as 5,000 kinds, almost all unknown to science. Here is a virgin area of biology. Now, whether I would work, I'd love doing that if I could start at the beginning, because that's a major area that's going to open up. But I do wonder about it. If I started there instead of ants, would I end up thinking about humans? Maybe not. What I'd be thinking about, I believe a young microbial ecologist would be thinking about, I can't wait to get those samples back from the aqueous layer of Mars, from drilling through Europa and getting the first stuff. That's what I would be thinking.
And you know what? I should bring some microbiologists and put them around the table and just say, what do you do? What is it you're about?
Well, they do all sorts of things.
Exactly.
All the way from Ebola to figuring out how life got started spontaneously.
So somebody picks this book up and says, The Meaning of Human Existence. Okay, Dr. Wilson, tell me what the answer is. What is the meaning of human existence?
I'll have to just, because I know our time is limited, just answer with a couple of general statements which I think carry the meaning of the meaning. First is that history makes no sense without prehistory. Prehistory makes no sense without biology. Human existence is a result of long series of evolutionary and cultural events, the cultural starting primarily when agriculture was discovered, that led up to what we are today. And the meaning then is the actual history, the epic, that goes all the way back to the origin of our biological imperatives. And then I would say, let us consider that human beings are, above all, a biological species in a biological world, that we live in a razor-thin layer of the atmosphere within which life can exist and to which we, as a species, are exquisitely well adapted. So it's when we get this understanding of where we are and what we are and where we came from, we'll be better prepared to decide where we're going.
E.O. Wilson, thank you.
Thank you, sir.
Pleasure, my friend. Great to see you. Thank you for joining us. See you next time.